Hello friends, the topic for today is software process. Software engineering encompasses a process, a collection of methods and practices, and an array of tools that allow professionals to build high quality computer software. Software engineers are responsible for applying the software engineering process. Software engineering is important because it enables us to build complex systems in a timely manner and with high quality. It imposes discipline to work that can become quite chaotic, but it also allows the people who build computer software to adapt their approach in a manner that best suits their needs. You build a computer software like you build any successful product by applying agile, adaptable process that leads to a high quality result that meets the needs of people who will use the product. You apply a software engineering approach. In today's video, you will learn the software process, its framework, umbrella activities, and process adoption. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you get notifications for videos, future videos on this subject. The topic for today is software process. Let us start with the introduction. A process is a collection of activities, actions, and tasks that are performed when some work product is to be created. So, process basically is a collection of activities, actions, and tasks. Let us see what is activity. An activity strives to achieve a broad objective and is applied regardless of the application domain, size of the project, complexity of the effort, or degree of rigor with which software engineering is to be applied. So it is a it has some objective. So for example, communication with stakeholders. Now this is an activity where we communicate with the stakeholders and try to get the requirements of the project from them. So that is a activity. Then action. An action encompasses a set of tasks that produce a major work product. Here, if you take for example architectural design. So when you do this architectural design, you will get an architectural model. So that is the work product which we get from the action. Whatever action we do, as per that we should get the work product. Then task. A task focuses on a small but well defined objective. So that produces a tangible outcome. So for example, conducting a unit test. Say you are you want to test a unit. So that is an task. So here the task is a small but well defined active say work or which has an objective. Okay, and it will give some output. Then let us go further. In the context of software engineering, a process is not a rigid prescription of how to build a computer software. So here we don't have a rigid process. Instead, it is say adaptable or it can be changed, flexible. It is an adaptable approach that enables the people doing the work to pick and choose the appropriate set of work actions and tasks. So here the software team is involved in the project. So the software process is adaptable approach, and we have to choose the appropriate set of actions and tasks. The intent is always to deliver a software in timely manner and with sufficient quality to satisfy those who have sponsored its creation and those who will use it. So this intention or the main aim of using the software process is timely delivery of the software and with quality. So those who are the sponsors or customers and those who are going to use it, they should be satisfied with that. Then let us see the process framework. A process framework establishes the foundation for a complete software engineering process by identifying a small number of framework activities that are applicable to all process software projects, regardless of their size and complexity. Now, in addition to process framework, there are umbrella activities that are applicable across the entire software process. We are going to see it later. A generic process framework for software engineering encompasses 5 activities: communication, planning, modeling, construction, and deployment. Let us see the first two activities, communication and planning. Communication. Before any technical work can commence, it is critically important to communicate and collaborate with the customer and other stakeholders. So here the customer is one who is making the software, is has the requirement of the software, and the stakeholders, those who are going to use it, users, they are one stakeholders, and those who are going to uh, develop it, the team, they are also the stakeholders. So now there has to be a communication and collaboration with these people so that we can get the proper requirement of the project. So here the intent is to understand the stakeholders objective for the project and to gather requirements that help define software features and functions. So that is the main intention of the communication. Then next is planning. Any complicated journey can be simplified if a map exists. A software project is complicated journey and planning activity creates a map that helps guide the team as it makes the journey. So the map is called a software project plan. So that defines the software engineering work by describing the technical tasks to be conducted, the risks that are likely to occur, and the resources that will be required, the work products to be produced, and the work schedule. So all the things are put in the software project plan. So planning is very important because we have to go as per the plan. So here in the software project plan, we have the work schedule that defines say, the activities, how they will be scheduled during the project. And then what are the risks which are going to occur in the project and the tasks to be conducted. So all these are defined in the software project plan. So if that is followed, then it will be easy to make the or develop the software. Then next is modeling. So here modeling, before we go, we'll just see what other projects they are doing. Say for example, landscaper, a bridge builder, or an aeronautical engineer, a carpenter, or an architect. So they work with models every day. So in that they sketch sketches are created that will understand the big picture, what it will look like architecturally, how the consistent part of fit together, and many other characteristics. So these are the things we call it as the sketches or the drawings. Then if required, you refine the sketch into greater and greater details in an effort to better understand the problem and you are going to solve. So that is how the projects in the other fields, even like civil engineering, aeronautical engineering, or any other projects, they will also have the drawings. Similarly, a software engineer does the same thing by creating models to better understand software requirements and the design that will achieve those requirements. That is the main purpose of modeling. Then next is construction and deployment. So construction, what kind of design must be built? This activity combines code generation, that is either manual or automated, and the testing that is required to uncover errors in the code. So the construction of the project, generally it will include the coding part and the testing part. Then deployment. The software is delivered to the customer who evaluates the delivered product and provides feedback based on the evaluation. So uh, as a complete entity or partially completed increment, we can deliver the software. So when we deliver it as a partially completed in increment, then we can get the feedback and improve on that. And when you deliver the complete entity, again it is evaluated and you get the feedback for that. Then it will be difficult to make the changes when it is complete. So that's why partially completed software also you can take the feedback before going further. Then these 5 generic framework activities can be used during the development of small simple programs, the creation of web applications, and for the engineering of large complex computer based systems. The details of software process will be quite different in each case, but the framework activities remain the same. So here we have to understand this part. So this is a general framework, or call it as the generic framework activities. And for a complex computer based system or web application, these activities will be different, but uh, the framework will be same. That is what we have to understand. Then for many software projects, framework activities are applied iteratively as a project progresses. That is, communication, planning, modeling, construction, and deployment are applied repeatedly through a number of project iterations. Then each iteration produces a software increment that provides stakeholder with a subset of overall software features and functionality. As each increment is produced, the software becomes more and more complete. So with the help of the feedback from the stakeholders, we can improve every time on the increment, and so that the software becomes more and more complete. Then let us come to the umbrella activities. Now, software engineering process framework activities are complemented by a number of umbrella activities. So these are applied through a software project uh, and help the software team manage and control progress, quality change, and risk. So typical activities include, we'll just see one by one. First is the software project tracking and control. So software project tracking and control allows the software team to access the assess the project progress against the project plan and take any necessary action to maintain the schedule. So for maintaining the schedule, this will be useful. So that is nothing but the tracking of the project, and accordingly we have to control the project. Then next is risk management. So this is, it will assesses the risk that may affect the outcome of the project or the quality of the product. So this risk management is very important in software development. So that each risk has to be assessed properly so that the project does not fail. Then software quality assurance defines the and conducts the activities required to ensure the software quality. So this is another check for the quality of the software. Then umbrella activities will continue. Technical reviews. So it accesses the software engineering work products in an effort to uncover and remove errors before they are propagated to the next activity. That is, with the help of the technical reviews, the errors are corrected so that they are not propagated to the next activity. Then next is measurement. It defines and collects process, project, and product measures that assist the team in delivering software that meets the stakeholders' needs, can be used in conjunction with all other framework and umbrella activities. So here we take some measurements. So it will include the, say, process, project, and product measures. So whether the product we are developing is as per the needs of the stakeholder, that will be checked with the help of these measurements, and can be used in conjunction with other framework and umbrella activities. So this is generally done with the help of, say, either we can have the external team or internal team. Then software configuration management. So that affects the change throughout the software. It will, whatever changes are being done, so that we call it as the configuration management. And we have to keep the track of this. There is a separate thing that is for configuration management. Then reusability management. So defines criteria for work product reuse. That is the reuse of the work products, including the software components. So some of the software components are reusable, and establish mechanisms to achieve reusable components. So that's why many times you see the softwares which are being built has got a lot of reusable components. For example, if you take any Windows software, it will have the, say, if you take the dialog box, open dialog box, it will be common to many of the softwares. Say, or the save dialog box, it will be similar. So that is how they are using the reusable components. Then last is here work product preparation and production. So that encompasses activities required to create work products such as models, documents, log forms, and lists. So this the These are the work products which are used during the project. So models, documents, logs, forms. So forms are particularly the different input forms and the list. So they are created for the use in during the project. Then next we go for the process adoption. Now here we have noted that software engineering process is not a rigid prescription that must be followed dogmatically by the software team. Rather, it should be agile and adaptable. So this should be adaptable to the problems, to the team, to the project, and to the organizational culture. Therefore, a process adopted for one project might be significantly different from the process adopted for the another project. It will, so this will be varying. There will be a lot of differences. Even from company to company, the things will differ. So the differences in process adoption. First is overall flow of activities, actions, and tasks, and the interdependencies among them. So they may be different. Then degree to which actions and tasks are defined within each framework activity. So that will also vary from say one company or project to project and company to company. Then one also depend on the different types of projects, embedded project, and say if it's a web-based project, it will be different. Then degree to which work products are identified and required. Then the manner in which quality assurance activities are applied. So it is depending on the company what how much quality assurance activities they are doing for in the project. Then manner in which project tracking and control activities are applied. So that will also be different. Then overall degree of detail and rigor with which the process is described. Then the degree to which customer and other stakeholders are involved with the project. So here some of the companies they will involve the customer and stakeholders more. Some of them will not involve the customer and stakeholder much. Then the level of autonomy given to the software team. So that is also very crucial. In some of the companies, there is no autonomy given to the software team. They are having their own say fixed process, and the software team cannot make changes in that. So that is also different for each of the project and company. Then degree to which team organization and roles are prescribed. So that is also depending on the particular organization of the team. So and roles are also different for each of them. So these with this we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, Gmail, or Instagram. Then if you like the video, press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon for getting notifications for future videos on this subject. Then thanks for watching. Have a nice day.